inverse of a matrix or matrix inversion. So there are multiple ways to find out the matrix. The basic one is this one. That is, you need to understand adjoint of A and the determinant of A, and this is the inverse. By definition, the inverse of a n by n matrix, that is, we are talking about a square matrix. Row and column should be same. And this has an inverse which is called as B. It should also be n by n, same order. So when we take a matrix A and we multiply it with certain other matrix B, and if we get the identity matrix, even if we multiply B with A, we get the identity matrix, and the identity matrix is nothing but the matrix with all the diagonal element 1 other 0. Not all the matrices have inverses. That means there are matrices whose determinant is 0. Those are called singular matrices. So the singular matrices, they don't have inverse, because A inverse is all about the denominator will be the determinant of A. So if a matrix has an inverse, then it is called invertible. Okay. So by definition, if you see, if A is a square matrix and if a matrix B of the same size can be found such that we have AB equals BA equals I. The row and column should be equal. A we are calling B as an inverse, and B we are calling A as the inverse. So A here we call it as invertible, and B is called an inverse of A. In this case, B is inverse of A and A is inverse of B. So A is said to be invertible and B is called the inverse if we say A cross B or A multiplied by B is equal to I. If no such matrix B can be found so that A into B is equal to I, then we call, or then we say A is said to be singular. Singular means their determinant is going to be 0, and division by the determinant, which is actually equal to 0, singular matrix, is not defined. So we write how this is the notation. So if we say A multiplied by B equals identity matrix, so B will be equal to A inverse. If we do BA, if this is equal to I, then we call this B was A inverse. Now in this case, A is equal to B inverse. There are certain properties of a matrix inverse or inversion of matrix. If the matrix we are calling it as A is an invertible matrix, then the inverse will always be unique. That is, if we multiply A with B, B we are calling as the inverse, then it is unique. We cannot have A along with C which also gives you I. That is the identity matrix. If you take the inverse of an inverse, that is, you take A inverse and you take the inverse of the inverse, then the same matrix will come. Inverse of the inverse is the same matrix. Then we have another property, that is, if the matrix has some power, say A raised power k, and if we want to find out the inverse of this, and this is same as we can exchange the position of -1 and k. That is, we can take first the inverse, then we can have the power or raise k. So we can also denote it multiplied k multiplied by -1, so we can also denote it by A raised minus k. So we can interchange it basically. Now when we have a matrix which is multiplied by some certain scalar, that is C into A, and C should not be equal to 0, you'll just know why. So if we have a constant C and if you have a matrix A and you're trying to find out the inverse, when C comes out, what it will be? It will be C inverse. And there is already A inverse. And C inverse is nothing but this is a constant, so it is 1 by C. So 1 by C, A inverse. So C cannot be 0 because division by 0 is not defined. Division is not defined. That is, C should not be equal to 0. That is the scalar value or a constant value. Now, if you take A and you take the transpose and you try to find out the inverse, this is equivalent to first you take the inverse and then you take the transpose. Now, if A is an invertible matrix, then we can have certain system of equation, that is, ax plus by plus c type of equation, and then we can represent it using ax equals b. So this x can be found out. How? X can be equal to a inverse b. So the a goes on the right hand side, it will be a inverse b, and this is how we can find out the value of x. So how do we calculate the matrix inverse? The easy way is take the inverse, and that is only division of two things. The numerator will have the adjoint of a, and the denominator will be the determinant of a. Adjoint a is nothing but the transpose of the cofactor matrix. I'll just show you how. So determinant you know already. So before you go ahead, adjoint a and determinant a should be very clear. So what is an adjoint matrix? So the adjoint, for that adjoint you need to have minors and cofactors. So what is the adjoint? Adjoint of matrix A is, first you will take A, then you will try to find out the cofactor matrix of A, and once you find out the cofactor, you will take the transpose of that cofactor. Just change the row and column, that will be the final adjoint. So the minor, when you take an example, for example, we have a 3 by 3 matrix. So the minor of any element of this 3 by 3 matrix or any matrix, how do we find? We find it by removing the ith row and jth row, that is the intersection where that element lies. We don't take that into account. Others, whatever is remaining, we take the determinant of that matrix. And what is because cofactor is basically a minor with the sign, so it will be minus 1 to the power I plus j. I and j are the row and the column number. I and j are row and column number. So minus 1 to the power, whenever it comes to odd, it will be -1. Minus 1 to the power even will always be +1. So in order to find out the inverse of a 3 by 3 matrix, we have an example here. So first we have to find out the determinant. So A inverse, the denominator will contain the determinant. So for that we have to find out the determinant. So how many rows are there? 1, 2, 3 rows are there. This is 3 columns. So this is a 3 by 3 square matrix, 3 row, 3 column. Okay. So if you know how to find out the determinant, it is good. Otherwise, I'll just tell you in brief how to find out the determinant. We can expand it using any row, any column. So there are 3 rows, 3 columns, you can use any of this. For example, you are using third column. You are using, say, second row. So the sign will be like this. First element, second element, third element. The sign has come from minus 1 to the power I plus j. I and j are the row and column number. So when we take the second row, for example, we are taking second row here. So second row is, in order to find out the first you have to take 2, and since you are taking second row, you have to put a negative sign in front of 2, and you have to multiply by the values remaining, 1 minus 1 and 5 2. Then 4 will come. We are taking the second row, so 4 will come. So what we'll have? 2 minus 1 and minus 1 2. So plus sign will be there in front of 4. We are following that the sign convention. Then minus 0, and I'm not writing anything after 0 because it is 0 only. So for 0 you have to do it like this: 2 1 minus 1 5. We are not writing it because ultimately it will be 0. So now minus 2. So there, whatever is inside, because this is 2 by 2 matrix, it will be cross multiplication. 1 into 2, 2 5 into minus 1, 2 into 2 and minus 1 into minus 1, and you subtract them. So this is your final determinant. So the first step is done. For finding the inverse, the denominator we have found out. Now coming to the adjoint, because numerator is adjoint. So we will replace each element by its cofactor. So cofactor, how to find out the cofactor? I'll just tell you a few of these so that you understand. What is the cofactor of 2? You will hide the row and column where it intersect. Other values 4 0 5 2 you will write, and plus sign you will take from here because it is cofactor. Cofactor is minor with sign. So minus 1 to the power I plus j. For example, this has come. How this has come? This second row, this is third column. What is this? Second row, third column, A, 2, 3. So minus 1 to the power 2 plus 3 is what? Minus 1 to the power 5. And odd, because it is odd, it is going to be minus 1. So when we take 2, it will be plus. I hope you got the idea of the sign, because the minor with sign is cofactor. Okay, 4, now cross multiply. 4 into 2 minus 5 into 0, 8. So we will do it for every element. For example, we are doing it for 1. So you hide row and column 1, 2 minus 1, 0, 2 will come. And then you know what will be the signs. So 2 into 2 minus 1 into 0, and that is going to replace 1. Then for minus 1, what will be the cofactor? 2, 4, minus 1, 5, 2 into 5 minus 1 into 4, and that is going to be, and you are going to take the plus sign. And you replace this minus 1 with 14, right? Okay. So minus 1, the cofactor you have to find out. 2, 4, minus 1, 5. This sign has come from here. This is the sign. Minus 1 to the power I plus j. So this is how each and every element cofactor has to be found out. So for this, for 2, for 4, it will be 3. For 0, it will be minus 11. For negative 1, it will be 4. For 5, again, there will be row and column you are hiding, and the other value you are going to cross multiply. This is going to be minus 2. Then 2, it will be 6. So this is the matrix of cofactors. But still the adjoint is the transpose of this. Since we have the cofactor, we have to take the row and column, we have to change. This is the matrix of cofactor. Determinant we have already found out, minus 2. Now you have to take the inverse of it. So the row will become column and column will become row. For example, this is matrix A, and we take the transpose. The cofactor matrix, the transpose has to be taken. So 8 minus 4, 14. Then minus 7, 3, minus 11 will become the second column, and 4 minus 2, 6 will become the third column. And determinant is minus 2. And we divide it by minus 2. That basically we are dividing it by minus 2. So minus half multiplied by 8 is going to be minus 4. And you have to multiply minus half with each and every element. That is, 9 elements are there, 9 multiplication should be there. For example, minus half into minus 7 will be 3.5. Minus half into 4 will be minus 2. Okay. So this is the final matrix. This is your inverse of the matrix. A inverse, or the inversion of matrix.